Hi guys, we're going to go through the notes together. So make sure you have your notes out, pencil ready. We're going to define some words you already know. First definition is a central angle. A central angle is an angle whose vertex is at the center of a circle. So remember, you name a circle by its center point. So this is circle P. And so center, central. Just remember that. Center point, central. We have minor arcs, we have major arcs. Minor arcs are less than 180 degrees, and it's named by 2 letters. Major arcs are greater than 180 degrees, and they're named by 3 letters. Semicircles, they're equal to 180 degrees, and they can be named with 2 or 3 letters. Now we're going to find the measurement of some arcs. Again, this is what we did in our last chapter, so this is review. We know that SN and MT are diameters, and we know the measure of angle SPT is 51, and the measurement of NPR is 29. So go ahead and plug all that information into your picture and see if you can figure out the angle measurements. Go ahead. I'll wait. So if I didn't give you enough time, go ahead and pause the video. Here's the angle measurements. Now, I didn't write on here what type of arcs they were. So for A, that is a minor arc. B, a minor arc. C, that's a major arc. And for D, that's a semicircle. Okay, so now we have some new words. The first word is a tangent. Now, this is not the same kind of tangent that we did when we had the sine, cosine tangent. This is a different type of tangent. A tangent is a line that just touches the circle at one little spot. Now, when it touches at one spot, it always makes a right angle. So, just remember, tangent, right angle, and the two go hand in hand. So for the second line here, theorem, a line is tangent to a circle if and only if the line forms a right angle with the radius at the point of which it touches the circle. So go ahead on your picture, maybe label it like I did, that it's a tangent line and that it's a right angle. And lastly, if 2 segments are tangent to a circle at the same outside of the point of a circle, then the segments are congruent and the angles formed by the tangent lines are perpendicular. Okay, so notice I drew like a little face on it. I always call this like the party hat theorem because it looks like a party hat, like what you would wear to like a little kid party. Both sides are the same. Just remember, if both sides are the same, it makes it really, really easy. And we will come back to this in a problem later. Okay, now this first problem is kind of a toughie. What we're going to do is we're going to find the measurement of R, which is the radius. Now, go ahead and label like I labeled in mine. We need to find the right angle. So, first thing, you have to find the right angle. So I labeled it in red. Label it. Now, there are 2 radius, and all the radii are always the same, so I labeled it R in blue. So label it. Now, the side from K to G is not 9R, it's 9 plus R, or R plus 9. So again, I labeled it in blue, R plus 9. So what I'm going to do now is I'm going to do a Pythagorean theorem. So a squared plus b squared equals c squared. So which 2 sides are the a and b? Well, I know the hypotenuse is across from the right angle. So R plus 9 has to be the hypotenuse. So notice for part B, I put R plus 9, I put parentheses, and I squared it. And it's equal to R squared plus 12 squared. Okay, so we need to practice multiplying this out. So what's R plus 9, all of that squared? So r plus 9, all of it squared, is the same thing as r plus 9 times r plus 9. Okay, so multiply that out. You could FOIL, you could do the box. R times R times 9, 9 times R, 9 times 9. Try to figure that part out. Okay, I'm waiting. You try it now. If you need more time, pause the video. Here's what you get. R times R is R squared. R times 9 is 9R. 9 times R is 9R. And 9 times 9 is 81. Now on the right-hand side, R squared stays R squared. And 12 squared is 144. Now, I have an R squared on both sides, so they're just going to cancel away. So let's clean it up. What's 9R, 9R? That is 15R. Okay, so now I'm just going to solve basic algebra, and I get my radius is 3.5. All right, take this in, write it down. Yeah, you're going to have to be able to do this on your own. So pause the video if you need to, write it down, and we will do more like this within the notes. Okay, now this one's different. It's not like the one we just did, that crazy problem. Okay, so when you look at this, it's kind of like the party hat theorem problem. You see two sides, they come to, they're segments, but they're tangent segments, so they make a right angle. So can you find out where those right angles are? Draw them in if you see the right angles. There's two of them. Okay, now the easiest way to do this is once you find the right angles is to say there's 360 degrees in a four-sided figure, and then subtract the two 90-degree angles, and then subtract the 35-degree angle, so you're left with 145. Now, a little shortcut way is to say that the x and the 35 together equal 180, and so you could subtract 35 from 180. So if I went way too fast, back it up, slow it down, whatever you need to do. This is the easy one, so you want to make sure you understand it. Okay, now we're back to one of the hard questions. Okay, so first step, find the right angle. Where's the right angle? Okay, find the tangent. Where's the tangent? The tangent where it touches the radius, that forms a right angle. So, draw it in. Now, my radius is x. You have another radius that's x. Write in x for the other radius. Okay, now once you draw an x for the other radius and you draw in the right angle, write in what the hypotenuse is. The hypotenuse is x plus 1. You're adding them together. Okay, so now we have to try to write the Pythagorean theorem out. So let's take the hypotenuse, x plus 1, and square it. Write it down. We're going to make it equal to the two legs. So x squared plus 3 squared. Okay, doing good. So now we need to FOIL that left side. Remember, x plus 1, all of it squared means there's two of them. So it's x plus 1 times x plus 1. You have to multiply it out twice. There's a middle term. So what is x plus 1 times x plus 1? Go ahead and multiply it out. Okay, so this is what I get. If I went too fast, slow the video down. X squared plus x plus x plus 1. On the right-hand side, 3 squared is 9. Okay, so now you need to clean it up. There's an x squared on the left and right. Cross out the x squareds. Now, what's x plus x? X plus x is 2x. You got it. So 2x plus 1 equals 9. So subtract 1 over and get 8, and divide and get 4. On this problem, we're going to take circle M, and it's inscribed within a quadrilateral, and we need to find the perimeter. Now, it's actually a lot easier than what it looks. Remember the problem where we had all the party hats? We're going to break this down into 4 party hats. Okay, so follow me here. Up at the top, one side, the right side is 9. That means the left side is also 9. You got it. Okay, so over here on further down, you have one little section that's 3. So that means the other little section is also 3. So continue doing that with the other 2 little tangents, which are party hats. And then we're going to find each of the measures and we're going to add them all together to find the perimeter. So go ahead and try, find the other 2 missing parts and add it all together. All right, so here's how I did mine. I found the 5 and I found the 2, and then on each side I just added them together, and I have a total of 38. So you guys double check me. I did this quickly. I believe it's 38. Okay, last problem. You guys almost made it. Determine whether a tangent line is shown in the diagram. Okay, so first of all, this would have to be a Pythagorean problem. So that means if I were to try to do Pythagorean, it would work. So let's try Pythagorean. My hypotenuse is 16.5. Is that equal to the 2 legs squared? So it all comes down to, are the 2 sides equal? Is 16.5 squared the same thing as 4.5 squared plus 10 squared? So grab a calculator. Let's start multiplying this out. 16.5 squared is, write it down, 4.5 squared plus 10 squared is, write it down. Are those 2 numbers equal? If the numbers are equal, then that really is a right angle. But if it's not equal, then it means it's not a right angle and it's not a tangent. So it's all just, you're waiting to see if they're equal. Now when I did it, I have that the numbers are not equal, therefore they are not a tangent. So this is really not a right angle here. So the only way it would be a tangent, again, is if the 2 numbers were exactly the same.